I got an email from a journalist who was writing an article about chemical bonding. He asked me what was the most surprising thing in my lifetime about chemical bonding. Fortunately, it was an email, so I had time to think. I'm not sure what I would have answered if I'd just been asked like that. But I decided that probably the most surprising things involved the noble gases. When I was in high school, about 14 years old, it was discovered that xenon could react with fluorine. Imagine it. There I was with chemistry teachers telling me noble gases don't react with anything, and then suddenly it's discovered, and not only is discovered that xenon will react with fluorine, but it was found that you could do it by just putting them both in a glass bulb and leaving it in the sunlight. Originally it was discovered in Scotland, where the sun isn't very bright. It took a whole week for the reaction to take place. Then they did it in Chicago, and it went, which is further south, brighter sun, went in an hour. Suddenly there was this new surprising fact. And the amazing thing was that really quite quickly chemists understood it wasn't so surprising, and they could explain the bonding. Then when I was a research student doing my doctorate, and a bit afterwards, we were working on very reactive compounds of chromium. And one of my colleagues, Robin, one of my fellow students, demonstrated that chromium in this compound could interact and react with xenon. This seemed really amazing. And we even made a model. Here it is. You can see it's beginning to be a bit faded, but it's got the chromium in the middle, and these 5 balls represent the 5 carbon monoxide molecules that were bonded to the chromium. This is so-called chromium pentacarbonyl. It's got 5 CO molecules, and the xenon was bonded on here. Robin didn't actually make enough of this material to put in a bottle, but he could observe its spectrum and even its colour. It was of an orange colour. The reason we made this model, and it's rather rusty now so it wouldn't work, was to demonstrate that you could change the angle between this bond here and these bonds down here. These were designed so that they would actually slide down. It's now stuck, but they used to slide up and down these slopes. What was interesting is that my colleague Jeremy Burdett, who sadly died some years ago, worked out that when the xenon came in here, these bond angles changed, and this changed the colour. And so there was a real surprise that xenon could interact with a metal. And this is perhaps, for me, what is the real surprise about xenon chemistry, that we then thought that xenon has the same number of electrons as iodide, I minus. And nobody's surprised that iodide can react with a metal. So if you think about it, the fact that xenon can also interact with a metal, perhaps not quite such a strong bond, but can still interact, is reasonably obvious. But what is surprising is that no chemist had thought about this until they'd done the experiments. And I suppose it is one of the great lessons about chemistry, because there's so many different atoms and so many different compounds, that very often you find something which is really surprising to you, But then when you think about it, you can see that you might have thought of it beforehand if you'd known all the facts.
We're taught that xenon is very stable. All the electron shells are filled, everyone's content, everything's neutral. What happens when fluorine comes along that breaks it apart, that makes things change?
Well, xenon cannot interact stably with one fluorine atom, because then you would upset the arrangements of electrons. However, if you have two fluorine atoms, it can, as it were, share one electron with each, and the three of them together can still have quite a stable interaction. It's not terribly stable. If you heat the compound up, it will decompose back into xenon and fluorine, but it will interact reasonably stably. Xenon and oxygen have a much more unstable relationship, and xenon trioxide is a fantastically unstable compound. Literally, if you tickle it with a feather, it will explode. Xenon is pretty inert compared to reactive elements like fluorine or sodium or something like that, but its reactivity is not as surprising as you might expect. And krypton will also form compounds, and again with fluorine, this very reactive element, you can just about get it to react with chlorine, but it's very unstable. But argon, neon and helium don't really form any compounds that are stable enough to do any sort of chemistry, though there have been some claims that argon can form complexes or compounds at very low temperatures.
Inside the balloon is then accelerated by the break